So today's class, we're going to be discussing section 13.3, arc length and curvature. And arc length is given by this formula right here, which is really similar to the arc length formula that you had before, except it just has this plus dz dt squared. Also, it could be thought of as this formula here, which is the length of the derivative of the vector valued function from the beginning point to the end point. So that's arc length. And we'll also take a look at curvature. And so what that is if it's a number that represents how much the curve is turning. It's basically the derivative of, since the unit tangent vector is always has length 1, so the derivative of the unit tangent vector divided by this is going to give you a larger number if the curve is turning, because then if the curve is turning, then the tangent vector is changing direction. And if the curve is turning sharply, then the tangent vector is changing direction faster. Whereas if the curve is just going along straight, then the unit tangent vector is just going to stay the same. And so the derivative here is just going to be 0 or close to 0 if it's making really small turns. Okay, so that's the curvature. And this right here is probably the most technical definition, but then there's all these other options for it. These ones are for if you have space curves. You can use any of those equations, probably this last one. And then if you have a plane curve, so you just have it in x and y, and you have like y equals f of x, and that's your curve, then you can use this simplified formula right here. Okay, so previously, we talked about the unit tangent vector. That's the derivative of the vector valued function divided by its length. So it's going to be a vector of length 1. Okay, the unit normal vector is the derivative of the tangent vector divided by its length. And the unit binormal vector is the cross product of the unit tangent vector and the unit normal vector. So let me try to give you an idea of what those mean. So let's say we have a curve, and it's going in 3 dimensions, okay? So let's say we're curving around, moving around. The unit tangent vector at a particular point is going to be like that. Okay, it's going to be length 1, and it's going to be pointing in the direction of in the direction that the curve is going. Okay, the unit normal vector, that one, let me do that in red. Okay, the unit normal vector, that's going to be pointing towards it's going to be perpendicular to the unit tangent vector, and it's going to be pointing towards the inside of the curve. Okay, now since these are 3-dimensional space curves, so it could be pointing in or it could be pointing out depending on the direction that the curve is going. And then the unit binormal vector right here, this is going to be, since it's the cross product of these two, then its direction is going to be, in this case, it'll be say out that way. It'll be something like this. So if this red one's coming out towards us, then the binomial vector would be going in, okay? And so it's just going to be So you have these three vectors that are perpendicular to each other. All of them are perpendicular to each other. Okay, and that's the formulas for getting those. Okay, so those are what we're going to be discussing today and doing exercises with those. So let's start with the exercises. We have number one is find the length of the curve. Okay, and so you remember from here, this is the formula right there. So it needs to be in the parametric form, which it is, so we're good. Okay, so the length is going to be, okay, so anyone want to guess what the integral would be?
The integral from 0 to 3 of,
Yes.
oh gosh. So it'd be the derivative.
Yeah, I guess we should have taken the derivative first. That might be easier. Okay, so what's the derivative?
It would be t to the,
It's just going to be root 2 because it's just root 2 times t.
oh.
And then e to the t is,
E to the t.
yeah, and e to the negative t is,
Negative e to the negative t.
okay, excellent. Okay, so now you're going to put these in, you're going to square each of these. So square root of 2 squared is going to be 2, and this is going to be e to the 2t, and then this is going to be, the negatives are going to cancel, and so it's going to be e to the negative 2t. Okay, so now you might be like, oh man, this integral looks pretty nasty. And maybe it does. But if you can rewrite this one, a lot of these problems, they really have to set it up so that you can do this. So here, let me rearrange the terms a little bit. So it's e to the 2t, I'm going to write it as e to the t squared. And then the 2, that's its just self. And then this I'm going to write as 1 over e to the t, because that's, and it's squared. So that's e to the negative 2t right there. Okay, now, does anybody recognize what this inside part is? If I look at it that way.
Is it the tangent?
No.
No.
Simpler than that. So it's something squared. All this is something squared. It's something plus something, quantity squared.
Is it e to the power t plus what is that? Plus
Yeah, e to the t plus 1 over e to the t, quantity squared. Okay, so if you square this, you're going to get this squared, which is that, plus that squared, which is that, plus double the product of these two, which is 1, so that's going to be 2 right there. Okay, and so this goes back to when you're doing arc length. Because in order to make it so they can be integrated, they have to do weird things like this. Okay. Okay, so this thing, so the square and the square root cancel off, so you get e to the t. And I'm going to go ahead and rewrite this back as e to the negative t dt. Okay. So then when you take the integral, you're going to get e to the t minus e to the negative e to the minus e to the negative t. Okay, and so that's going to go from 0 to 3, and so you put the 3 in, you get e to the 3 minus e to the negative 3, and then put zeros in, and you get e to the 0, which is 1. Oh, 1 minus 1. Wow. Okay, so e cubed minus e to the negative 3. Okay, let's see if that's an acceptable one. Let's see if Webassign accepts that. All right, did it. Okay, let's go to the next exercise. So here we have, let C be the intersection of the parabolic cylinder. X squared equals 2y. And the surface, 3z equals xy. Find the exact length of C from the origin to the point 32 over 3. Okay, so again, it's asking for a length of a curve, right? And so that means that we're going to use this formula here, which means that we're going to need parametric equations. Okay, so we have this intersection of this and that, and we need parametric equations of that. So let's go for that first, and then we'll figure out what values of t take us from the origin to that point. Okay, so any ideas on how to parameterize this? Okay, well, that's okay. You notice that here, y can be solved for in terms of x. So y is x squared over 2. Okay, so that's from this one right here. And then we also know that z can be written in terms of x and y, like that. So that means that x can be thought of as an independent variable. And then when that's the case, then to parameterize, you let x be t. And then if x is t, then what's y? What's y going to be in terms of? Yeah, t squared over 2. And then z, you can plug in a t for the x, and then you can plug a t squared over 2. And for the y part, all over 3. So z is going to be t cubed over 3. Okay, so your vector valued function is for the t position, for the x position, you just have t. For the y position, you have t squared over 2. And for the z position, you have t cubed over 3. And then what values of t? I should be a t in the middle. Okay, so what values here and here will give us, we'll run this curve from the origin, which is, of course, 0, 0, 0, to the point 32 over 3.
Oh, shoot.
Okay, so what value of t gives us 0, 0, 0?
0.
Yeah, 0 gives us 0, 0, 0. And then what value of t gives us 4, 8, 32 over 3?
4.
Yes, 4. Okay, so t is going to go from 0 to 4. Okay, great. So now we're going to calculate the derivative. So that's just 1. And then this is going to be t. And this is, whoa. Wow, all these, this 2 and the 3 in the denominator just like went away. Wow. Okay, so the length is going to be the integral from 0 to 4 of the square root of 1 squared plus t squared plus t to the 4th. Okay, oh dear. I don't remember how to integrate this thing. Anybody have any ideas?
No.
No.
Use one of the.
Oh.
Oh, you can pull out a square, can't you? Or no? Can you factor it?
Oh wait. Oh wait,
No.
I made a mistake. That's why. This is there's a 2 right there, so that's actually a 6. Which means that's a 6, which means that this is t squared over 2, which means this is t squared over 4. Or you can write it as t squared over 2 squared. Okay, here we go. There we go. That's a little better. What's this going to be now? That's going to be 1. And then here it's t squared over 2, right? Because it's going to be this squared plus that squared plus the product times 2. And then that just ends up just being 1 plus t squared over 2 dt. And integrating, you get t plus t cubed over 6. And that goes from 0 to 4. So it's 4 plus 4 cubed over 6 minus, and then there's just zeros there. So this is 12 over 4 is 12 over 3, and then this one is 32 over 3. So I get 44 over 3. Okay, let's see if that works. Okay, great. Okay, so let's move along to the next exercise. So we're looking at number 3. Okay, so it says find the unit tangent and the unit normal vectors. So that and that. Okay. Okay. So so we go back to the formula here. This is the formula for the unit tangent, and this is the formula for the unit normal. So the first thing we have to do is calculate r prime of t, because the unit tangent vector is equal to r prime of t over the length of r prime of t. Okay, so what's the derivative of r of t? Or the derivative of this?
7. And then what's the rest of it? -2 sine t, and then +2 cosine t.
Exactly. Okay, so that's going to be that. Okay, so the and then we can calculate the length r prime of t also. That's going to be the square root of the sum of the squares of all these. So 49 plus 4 sine squared plus 4 cosine squared t. So these add up to 4, so that's going to be the square root of 53. All right, so the unit tangent vector is going to be this divided by the square root of 53. So
Wait, Brother Hurst,
over,
what happens to the sine and the cosine?
what happened?
Yeah. Oh, or do they just become 1?
Yeah, that becomes 4. Yeah, all this combines to be, all that combines to be 4. So 49 plus 4. Okay. Yeah. Thanks for asking that. And then -2 sine t over the square root of 53, and then 2 cosine t over the square root of 53. Okay. So those are going to be the stuff. So okay, so that's the unit tangent vector. Let me see this. Okay, great. Webassign agrees. So now it's the unit normal vector, and the unit normal vector that is the derivative of the unit tangent vector divided by the length of the unit tangent vector. Okay, so here's the unit tangent vector. So we'll go ahead and find the derivative. Okay, so what's the derivative of that? So that's going to be 0, and then the derivative of that is going to, yeah, negative
cosine over root 53.
And this is going to be -2 sine. Okay, and then the length of the unit tangent vector is going to be the square root of, you got 0 squared plus, and then there's this squared. So that's 4 cosine squared t over 53, and 4 sine squared t over 53, which those two are going to combine to give you 4 over 53. But when you take the square root, it's going to be 2 over the square root of 53. Okay, so you're going to divide, so the unit normal vector is going to be this vector here divided by this 2 over root 53. or it's like it's multiplying by root 53 and dividing by 2. So basically, just wipe out this 2 over root 53 everywhere. And you have 0, negative cosine t, and then negative sine t. Okay, let's see if Webassign will accept that one. Okay, and then good, accepted it. Okay, so now the last one is to find the curvature. Remember, this is how fast the curve is changing. And it's defined to be the derivative of the unit tangent vector divided by the length of the, the length of the unit tangent vector, or the length of the derivative of the unit tangent vector divided by the length of the derivative of the vector. Okay, so and also Webassign tells you to use that formula. So the length of the derivative of the unit tangent divided by the length of r prime of t. Okay, so what is this right here? We actually calculated that. So the numerator is what? That's going to be this right here, right? So that's 2 over root 53. And then this one is from here. So that's just root 53. So the curvature is 2 over, you got root 53 over 50, so it's 2 over 53. Okay. So this is kind of interesting. This curve has a constant curvature. So for all values of t, it's just going to be constant. It's going to be 2 over root 53. Most curves are going to, the curvature is going to like, well, typically the curvature is going to change as you go around, as you move around the curve, and it twists and turns and goes up and down and stuff. Here, though, what's happening is because this, if you just look at those two right there, that's a circular kind of a motion, a constant circular motion. And then this right here is, you're just going out along. So it's just going to be like winding out along the x-axis. Okay, so the x-axis is coming out at you. It's just going to be curving around kind of a helix, coming out along the, circling around the x-axis. Okay. Okay, let's move on to the number 4. And that says find the curvature of this. Now, because we did this previous problem where we found the unit tangent and the unit normal, and it involved finding this value and that value, which is the curvature, then it was easy to just plug those. The easiest thing to do was just to use that other formula and just plug those, to use this formula and just plug those in. Okay, but typically, when you're not going to do all those things, then it's easier to use this formula here. Okay, they just use that formula there. So, or I guess it can be. Maybe, I don't know. Which formula, do you guys want to try this formula, or should we try this one? Do this one again, or try that one?
Which one's easier?
I I don't know at this point. I thought this would be easier, but that looks pretty nasty because it's like a second derivative and all that. But let's try this one anyways. Okay, let's try that. Okay. Just so that we have experience doing that one too. Okay. So the curvature, the other formula would be this, r prime of t, cross product with r double prime of t. And this is just the length of that cross product. And then that's divided by the length of r prime of t cubed. Okay, so great. That involves finding r prime of t first, which is going to be 3, 2t, and then 3t squared. And then the second derivative is 0 to 6t. Now the cross product of those two let's go ahead and set this up. So, and then the last is 0 to 6t. Only 1 0. Well, that's better than no zeros, I guess. Yeah, that's a lot better than no zeros. Okay, so multiplying this one, so you're going to get 12t squared in the I direction, and then this is 0, yay. And then this is 6k. Okay, and then subtracting, we have 0 that way, and 6t squared in the I direction, and 18t in the j direction. Okay, so you have this minus this is 6t squared in the I direction. And then in the j direction, we have minus 18t. And in the k direction, we have 6k. And you can factor a 6 out, and you're left with t squared, negative 2t, and 1. Okay, so we need to find the length of that. And if you factor a number out, like a positive number, then the length is going to be that positive number 6 times the length of this. Okay, so if you factor a positive number out, then the length will be that positive number times the square root of the other stuff. So t to the 4th plus 4t squared plus 1. So that's this squared plus that squared plus that squared, just like that. Okay, and then this part right here, here we have this vector, so that's going to be square root of this squared plus this squared plus that squared. Wow, I don't see how to simplify that anymore. So let's just let's put that in there and see what happens if they accept that. Wow, they didn't accept it. I'm hurt. After all that work, and they said, no, they're not right. Oh, I know why. Okay, so here's the problem. Once again, I didn't read the question right all the way through. It says at that point right there, at 311. Okay, so to get that point, to get this point, what value do we set t equal to that will give us 311 in here? Okay, what value of t will make this 311?
1.
Yes, 1. Okay, so we just need to put the 1 in right here. So that's 6. The square root of 1 plus 4 plus 1. And then this is 9 plus 4 plus 9. Okay, so 6 root 6 over the square root of 22. Whoa. We can factor a root 2 out and cancel it. So let's see if they accept that one. So instead of, we'll put root 3 and then root 11 in the denominator.
Nope.
Ah, good for nothing. Okay, so, wow. Let's try this, okay? Let's try this cross product here using these vectors instead, okay? Okay, so r prime of 1, because that's setting t equal to 1 gets that, right? It's going to be 3, 2, 3. Our double prime of 1 is going to be 0, 2, 6. Okay, so if we take those cross products, then, does anybody see where we made any mistake? Because that would be helpful.
I see negative 18 TJ. And I think when you take the 6 out, that's actually negative 3.
Oh, wow. Yeah, this is a 3 right here. Okay, so there we go. Okay, good. So that's a 3 right there. So that means that this is going to be a 9, right? Which means that's going to be a 9, which means this is, whoa. So this is a square root 11. So it's actually 6 over the square root of 2, or 3 root 2. Okay, let's try it. Let's see if that works. What? Still doesn't work. Okay, hold on.
Love this problem.
It's just not how it.
Ooh, this problem. No, this problem is just being. Okay, let's try. Let's continue along this path here. So J. Okay, so this is wait. This is 12 I right here, and that's 0 J. That's a J plus 6K. Okay, and then we're subtracting 0K and then 6I and a 18J, right? So that's 6I minus 18J plus 6K. And we factor a 6 out, that's going to be 1, negative 3, 1. Yeah, so it's just going to be this. 6 root 11. for the numerator. Okay, so denominator. Oh, wait a minute. I forgot this cube here. How silly. This is actually going to be 22 root 22 because of this cube right there. Ah, okay. So because of this cube, this is cubed, which means this is going to be 22 root 22. So this will be over 22. Okay, let's try that. Okay, great, finally. Okay, sorry for that delay right there. But finally, this answer works. Okay. And because remember, there's a cube right there. It kind of looks awkward, but that's right there. So I think in this case, it would have been easier to just go use this formula here. But a lot of times it's not. So, okay, let's move along to number 5. And it says, at what point does the curve y equals 3 log x have maximum curvature? And so again, you want to calculate the curvature, kappa of t. And now if you have this case, if you have it like that, then the way that you want to do it is to use this formula here. Okay. Use this formula right here for the curvature. The second derivative over the absolute value of the second derivative over all this. Okay, so let me write that down right here. So that's going to be the absolute value of the second derivative of x over 1 plus the first derivative squared. And that's to the 3 halves. Oh dear. Okay, that's if you have the curve as being y equals f of x. Okay, so this is like, so our f of x is 3 log x. So that involves taking 2 derivatives of that. So f prime of x, what's f prime of x? A derivative of this.
Would be 3 over x.
Yes, and the second derivative. Okay, so it's basically, if you think of it as 3x to the minus 1, then you're going to get negative 3 over x squared, yes, okay. So that's what you get. Okay, so now we can plug everything in. We can plug this 3 over x in here. Now, the numerator gets this one right here, right? The absolute value of this, which is just going to be 3 over x squared. Okay, so the numerator is 3 over x squared. The denominator, you get 1 plus this squared. So that's 9 over x squared. That's what that's going to be. And then everything's raised to the 3 halves. Wow. Okay. So this is in terms of x, not t, sorry. So that means that the curvature as a function of x, we can rewrite it as 3 over x squared times 1 plus 9 over x squared to the 3/2. Or this x squared can go inside. So let's see, what does it go in as? Let's see here, let's think about that. So we're looking at this x squared here. So x squared is equal to what raised to the 3/2? X raised to what power? It looks like 4/3, right? Because if you take 4/3 and multiply by 3/2, you're going to get 2. Okay, so that becomes, so this goes in as x to the 4/3, and then we have wait a minute, actually, actually we don't need, I don't think that's it. I don't think we need to do that actually. Let's do the opposite. Let's do the opposite. Let's not do that one. Let's okay, let me back up here. Okay, so instead of doing that, let's factor an a 1/x squared out of this. Okay, so by that I mean that this will be the 1/x squared here times x squared plus 9, right? Okay, so this times this is going to be just 1, and then this times this is going to be 9/x squared. Okay, now we have 1/x squared. This one right here, but that's raised to the 3/2 power. So that's going to be 1/x to the x cubed, right? Okay, so this comes out as an x cubed, as 1/x cubed. Okay, so bottom line is what's going to happen is this is going to come out as an x cubed, so it's going to be x squared over x cubed, but I'll put an x up to the, so it ends up being 1/x, which means that the x goes up to here. And in the denominator, we have x squared plus 9 to the 3/2. Okay, and let me rewrite this as 3x times x squared plus 9 to the negative 3/2. So that is our curvature right there, is this. This is our curvature. And it says, at what point does the curvature have maximum, or does the curve have maximum curvature? So you want to maximize this. What's the maximum value that this is going to be? And so what do you need to do for that? If you want to find a maximum of a function, then you do what? You guys remember?
Just take the absolute value.
No, not the absolute value. You take. Okay, so if you have a function, okay, let's say you have a function. Let's say a function does this. Okay, and you want to find what that value is there. Okay, so
then you just test numbers.
Okay, so first of all, you guys don't remember, really, this is calculus 1. This was calculus 1.
You test numbers in the negative, positive, and 0.
You test numbers.
The vertexes is where it's like, that's where the slope is 0.
Yes. Okay. Yeah. So you want the slope 0. So that means that you're gonna take the derivative.
Right.
Okay. So maximums will occur where the slope is 0 or undefined. Okay. So we take the derivative of this and use the product rule. So it's the derivative of the first part, 3, times the second part, times the derivative of the second part, which is saying that's negative 3/2 x squared plus 9 to the negative 5/2. So that drops by 1 power. And then multiplying by the derivative inside, which is 2x. But you still have this 3x here. Okay. So that's going to be, so you're going to be minus that. Okay. So we have this first one. I'm going to rewrite it like this. Okay, so this is equal to this, right? Because this one right here is 3 over x squared plus 9 to the 3/2. And then 5/2 is just one more. So I put that right there and I added one there. So this, so if I was to take one, so if this would cancel this down to 3/2, which is there. Okay, right here, the 2's are going to cancel, right? And let's see, the numerator, and then this goes down to the denominator as x squared plus 9 to the 5/2. And then we end up with, there's a 3 here, 3 there, so that's 9. And then we have x, 2x, x squared, 9x squared. Okay? Okay, so then if you distribute this out, you're going to get 3x squared plus 18 minus 9x squared. And that's all over x squared plus 9 to the 5/2, or negative 6x squared plus 18 all over this. Okay, this is never a 0. This is always positive because you're taking something and squaring it, which is going to be greater than or equal to 0, and you're adding 9. So for sure it's going to be positive. So the only case is where this is 0. So 6x squared equals 18 is what that comes down to, or x squared is 3. So we're going to say x is the square root of 3. Plus or minus the square root of 3. I'm just going to go with the plus square root of 3. We can go into more detail if you want, or we can just like say the square root of 3. Negative root 3 is not going to work in here. It's not even part of the domain. So the domain is positive value. So this is the only value that can work. That makes this 0. This is the only value, root 3. So if x is root 3, then y is going to be 3 times the log of root 3, which you can probably, let's try to see if that works, see if that point works. So square root of 3, and then 3 log of square root of 3. Dang.
So what do we type where?
I got it wrong.
Yeah, okay, so here's the problem. Can't believe I did this. So this is a 27, not an 18. Okay, because 3 times 9 is 27, not 18. I can't believe it. Okay, so this is 27 also. So that means that x squared is going to, or let me just knock all that out. Okay. Go away. Go away. Okay, so x squared is 27. That means that x squared is 27 over 6 or 9 over 2. Okay, so you get 3 over root 2 as the only possible value. Okay, and then, so then y is 3 log of 3 over root 2. Okay, so let's try that one.
Dang, this is a long problem.
Okay, well, at least that works. Yay, that worked. Okay, so the answer is this, 3 over root 2, and then 3 log of 3 over root 2. Yeah, all these problems are long. And then, so the thing is that and there's lots of opportunity to make mistakes. So that just kind of draws it out. Okay, so I'm kind of showing you the experience that you're going to have when you're doing the homework, if you're a normal person. But if you're like abnormal and you never make any mistakes, then this probably won't be your experience. Okay, so now, what happens to the curvature as x goes to infinity? So we're looking at the limit as x goes to infinity of this one right here. 3x over x squared plus 9 through 3 halves. And anybody want to take a crack at it? And what the answer would be? So the numerator is like x to the first power, right? And the denominator is like x squared to the 3 halves, which is x to the third power. So you basically have x over x cubed. And as x goes to infinity, this is going to go to 0. Okay, so the answer is 0 for that part. Okay, so we just have one more problem to do, and that is for this vector, we want to find t and b. Now remember, those are the vectors that this forms. Some people call this the t and b frame, and so that forms the vector that the unit vector that's tangent, unit normal, and unit binormal vector. Those 3 there. Okay. So let's go ahead and find those. Okay, so first of all, the unit tangent vector. And that again is the derivative over the length of the derivative. And now this time I'm going to remember that that's at that point, at this point here. What value of t will get us this point? Let's figure that out first. So what value of t, when you plug it into here, is going to give us the point 4, negative 16/3, negative 2.
Negative 2?
Yes, negative 2 does it. Okay, because that's going to be 4, and that's going to be yeah, and then everything's going to work out. If you plug, so plugging -2 into here gives us this. Okay, so let's go ahead and calculate the derivatives. R prime of t, that's going to be 2t. And then this one is going to give you 2t squared, and then that's going to be 1. And then if you plug in -2, that's going to be -4, and that's going to be 8, positive 8, and that's going to be 1. So the unit tangent vector is going to be this one divided by the length. Now, usually when you do this, though, you don't write a big line like that. You usually have your length right here. And also, I probably should have said that -2 right there.
Question?
Yes,
Where did you get the -2 from?
Taylor told me to use it. It's the value of t that you plug into here that gives this point. And I guess the biggest indication is that this last one is just a plain old t, and that's a -2. So to have any chance, the t is going to have to be -2.
I got it. Thank you, Taylor.
Yeah.
Hey, no worries, you anytime.
Okay. So, the length is going to be the sum of these squares. So that's 16 plus 64 plus 1, which is the square root of, whoa, wow, the square root of 81. Well, that's just going to be 9. Okay, so we have a 1/9 right there. So for the unit tangent, you carry the 1/9 in to the vector like that. Okay, and let's see if that works for the unit tangent vector. So remember to use the brackets from vector notation. Okay, so that works. And then the next one is to find the unit normal vector. Okay, and the unit normal vector, that's going to be the unit tangent, the derivative of the unit tangent vector over the length of the unit tangent vector, -2. Okay, so this is, okay, so now I realize that I didn't do this in a good way, because in order to find the derivative of the unit tangent vector, you have to find the unit tangent vector as a function of t, not as the values here. So that's kind of unfortunate. So that means that I have to go back to this step right here. I have to go back to that one and do this right that. I have to find t of t. Okay. Okay, so that's just going to be this one here. Let's do this. First of all, let's find with this right here, the length of r prime of t. So that's going to be the square root of 4 t squared plus 4 t to the 4th. I'm just squaring each of these plus 1. Okay, and then, so, oh, this looks really nasty. I don't know if I want to do this. I don't want to do this, but we have to. Okay. How the? No. Okay. So it's this vector divided by that. So it's this divided by each one divided by that. But let me do this though, because we're going to need a lot more space. Okay, so you have 2t divided by all that. But I'm going to rewrite it because we have to take the derivative. That's the problem. Okay, so I'm going to have this 2t. It's divided by all that. So instead of dividing though, I'm going to multiply by this to the negative 1/2. Okay, and then it's 2t squared times the same thing. And then it's 1 times the same thing. So okay. So derivative time, oh dear. Actually, we need even more space for the derivative. More space. Let me just grab more space. Oops. Okay, so the derivative of this first one, oh dear. So that's going to be 2 times this. Times the derivative of the second part times this first part here. So you have the first part times the derivative of the second part. So you have a negative 1/2 come down. And you also have the derivative of the inside part. That's going to be 8t plus 16t cubed. And then we have 4t squared plus 4t to the 4th plus 1 to the negative 3/2. That's for the first spot. And then the second spot is going to be the derivative of this part, which is going to be 4t times that to the negative 1/2 plus the derivative of this part times that. So that's 2t squared. Then you have a negative 1/2 coming down. Oh, wait, this negative is already there. Times the derivative of this part, which is 16t plus 16t cubed. And then this whole thing to negative 3/2. And then the last one is just going to be negative 1/2 times 16t plus 16t cubed times all this to the negative 3/2. Okay, now we're going to plug a negative 2 in for t. And so that gets us, let's figure out a few things really quick. It seems like we're just wasting time here because probably we're going to end up with the wrong answer in the end. Maybe we should just not do this problem. No, but we could do it in 4 minutes, right? Okay, so let's make a little function here. F of t is 4t squared plus 4t to the 4th plus 1, and that's to the 1/2. And just figure out what that is. Figure out f of -2, because that appears all over the place. So you can figure that out, then we're great. Okay, so if we put a -2 into here, that is going to be 16. This is going to be 64, and that's going to be 1. Hey, it's 81. Okay, that's good. So this is 9. Wow, okay. Okay. So that means that all this is 2 over 9. Okay, then these guys cancel. This negative was part of that one. Okay, so now this is negative, but then this is negative also. Wait a minute. Yeah, okay. So this is going to be -2, and then this is going to be -16 minus, what's 8 times 16? 128.
Yes.
And this one, this is going to be over, this makes it over 9 cubed. So 9 times 9 times 9. Okay, that's the first slot. Second slot is going to be 4 times -2 over 9 right here. And then this is going to be, the t squared is 4. This is going to be 1/2. And then this is also going to be all this mass right here. Wait, put a -2 and that's -32 minus 128. Wait a minute, how do I get an 8t there? And a 16t there. That should also be 8. Okay, so this is -16 minus 128, and that's all over 9 times 9 times 9. And then the last slot is going to be -1/2, and this is going to be 8. 8, no, 8t, that's -16. Minus 128, and that's also over 9 times 9 times 9. Dear, this is just really bad. Okay, that looks like about all the time we have for. So I'll tell you what, I will just work through this and then post the answer back up on the website. Okay. This is kind of, it just takes me a little bit more time to run through this on the calculator, as I could on paper I could probably whip it out faster. Okay, so I'll just go through this and put the answer up on to post the answer online. Okay.
Thank you, Brother Hurst.
Thank you, Brother Hurst.
Thank you for writing so
Sure.
much.
Yeah. I think you should take out the homework that's on there.
I should what? Take it off the homework? Man, you put this kind of problem on the homework, and you don't expect that this is going to be so nasty. It's like, what is this? It's just like t squared and t cubed. How bad can that be? But I was
This-
definitely wrong there.